Hi, this is Math 6, Unit 4, Lesson 1. Okay, we're looking at dividing fractions in this unit, so this is the first one of the lessons. So we begin with the size of the divisor and size of a quotient today in today's lesson. So these are some important words that we're going to talk about as we go through it, what a divisor is and what a quotient is. So expect those to pop up here as we talk about things. So first of all, number talk, size of dividend and divisor. All right, so it says to find the value of each expression mentally. So we have a value here. We have 5,000 divided by 5, and they want us to find what that value might be, just thinking about it. So if you were to think about having 5,000, let's just pretend like it's money, $5,000, and you had to divide that and share that with 5 friends, how much money would each friend end up getting, right? So if you have a friend number 1 and friend number 2 and friend number 3 and friend 4 and friend 5, everybody's going to get $1,000 a piece, and that would be an easy division of the 5,000 because we take the 5,000, we break it up into 5 groups, and everybody gets $1,000 a piece. Okay, that works out okay. So if I have a large number divided by a small number, we still end up with a pretty big number, right? Now if I take 5,000 and divide it by 2,500, the number of how, if I have $5,000 again and I'm sharing it with 2,500 friends, it's going to be a smaller answer than what I had over here with 1,000, right? Because I'm sharing the same amount of money with a lot more people, right? So we're going to have something less than 5,000 still because we're still breaking it up. And I might recognize that 50 or 5,000 is 2 times what 2,500 is, or this is about half of that. So what we would say is that essentially everyone's going to probably end up with $2 or 2 each, because if I take 2 and I multiply 2 by 2,500, I end up back at 5,000. So everybody would get 2, because this is taking 5,000, dividing it by half of that, 2,500, gets you 2 on the top. Okay. Again, you can think about it mentally like this. It's like a fraction, 5,000 divided by 2,500, like so. And when we have something like that, we can eliminate the zeros there, and you end up with 50 over 25, and 50 over 25 becomes 2 over 1, which is simply 2. This next one, though, we can see that now our 5,000 is a smaller value than the 10,000. In fact, this is twice as much. So if you think about like the inverse of what we did before, if over here, if this became 2, when we had to multiply 2 times 5,000, or 2 times 2,500 to get to 5,000, think of it this way. What number am I going to multiply by 10,000 in order to get back to 5,000, right? So in this case, I multiply by 2 to get there. Here, knowing that this is double that, I'm actually going to multiply by a half in order to get there. So if I took $5,000 and I divided it by 10,000 people, everyone's only going to get half, or 50 cents, right? That's what you end up with. And then finally, our last one here, you have 5,000 divided by 500,000. So again, imagine you have $5,000 and I'm going to share it with 500,000 people, right? That's 5,000 divided by 1, 2, 3, 1, 2, 3, like this, right? And when you work that out, you can reduce your zeros here like so. So you end up with 5 out of 500, and that becomes 1 out of 100, which is not a lot of money. So basically everybody, if this is $5,000, would get a penny. Not a lot of money there. So just an idea how you look at that. So we're going to be talking today about how when we divide numbers, whether big or small, how that has an impact on what your quotient is going to be, your solution is going to be. All right, let's look at activity number 2. Activity 2. Here are several types of objects. For each type of object, estimate how many are in a stack that is 5 feet high. And again, we're just estimating here. Okay, and just be prepared to explain your reasoning. So you have some cardboard boxes, a notebook, bricks, and some coins, and the idea is to estimate how much would these be, or how tall would they be if they were 5 feet high, not how tall, how much of each type is what we're looking for. So how many are in a stack? So a cardboard box, I'm not sure how big a cardboard box is. I moved some people recently. If a cardboard box had a height of, let's say if it was 1 foot high, right? If a box had a height of 1 foot, then we would probably say, in that case here, that we would have 5 of them, 1, 2, 3, 4, and 5, in order to get to the 5 feet. So if the box was 1 foot, we would say it would take 5 boxes to reach a height of 5 feet. That makes sense, right? Again, that's a simple number. If each one is 1 foot tall, it works out pretty well. Again, we're just estimating. Explain your reasoning here. When I look at a brick, I'm not sure how big a brick might be. A thickness of a brick, if we talk about one brick here, let's draw a brick here. A brick might be something like 2 inches tall, right? So maybe it's 2 inches tall, and that's how tall it is. Now I want to get that brick all the way up to 5 feet. If I stack them up, I want to make that up to 5 feet. So how many 2 inches are there going to be in 5 feet might be what you're thinking about. And again, 2 inches is just my estimate. So in your class, you might estimate to be 3, you might estimate to be 2.5. It doesn't matter. Again, explain your reasoning. So if a brick is 2 inches tall, I know that it's going to take 6 bricks, 2 times 6, to get me to 1 foot, right? Because that's 1 foot. And so 12 inches equals 1 foot. So I would need 6 bricks to get to 1 foot. Okay. Now to get to 5 feet, I'm going to multiply that 6 by 5, and I end up with 30. Why? Because 6 times 5 and 1 times 5, it's going to give me 30 inches, which is 5 feet. And so that's how that's going to work out for me. All right, so actually more than that, but that's okay. Yeah, so 60 inches, but 30 bricks, 60 inches, and 5 feet. So I'm going to have 30 bricks in order to get to 5 feet, because I'm going to say that each brick is equal to 2 inches. Okay? If you thought of a different height for your brick, that's fine. If you thought 3 inches, then you'd multiply it a little differently, but I did it with 2. For the notebook. A notebook generally, like if I think about my teacher's book here for this one, you know, here's my teacher's book for this unit, and it maybe is, you know, maybe an inch, maybe half an inch, depending how you look at that there. But a notebook that you might have, maybe to take notes in, might be maybe about a half an inch thick. Half an inch. Maybe it's about the width of a notebook, of a typical notebook, half an inch. Just again, it's an estimate. What do you think it might be? So if it's a half an inch thick, we know that it's going to take several of those to get to be at least a foot, and then let's get to 5. So to get to a half an inch, if I multiply that half by 2, so 2 notebooks is going to be 1 inch. So 1 inch gives me 2 notebooks. Okay. So if I want to get to 12 inches, which is a foot, that's multiplying by 12. So 2 times 12 is 24. So 24 notebooks is how many it takes to make 1 foot. Now, if I want to make 5 feet, I'll multiply 24 times 5, and we end up with 120. So it takes me 1 notebook is half an inch. So actually 1 notebook is half of an inch. 2 notebooks is 1 inch. 24 is 12 inches or a foot. And then if I multiply that 1 foot times 5 to get 5 feet, it takes 120 notebooks. All right? So a little bit of a table work there, but that does work out as we're looking at those notebooks. Okay? We're taking this height of 5 feet and we're dividing it into segments of about a half. And when we chop that into half-length segments, we end up with 120 of those. Okay? Now finally, when I get to the coin, all right, here's my coins. Now let's imagine my stack here is at 5 feet. So there's my 5 foot. That's my idea. On the prior one, we chopped that 5 foot up into half-inch segments. Just like over here, we chopped the 5 foot up into 2-inch segments. And, you know, it's not to scale. And our first one, we chopped up into 1 foot segments. Okay, so if you go look back, this 1 foot, 5 foot became 1, 2, 3, 4, 5, right, for our 5 boxes. When we did the 5 feet as an inch thing, then we ended up with 30 of these things, right? So you took your 5 foot and we chopped it up into 30 pieces, so much more. Again, hard to draw that there, and this became 120. So now with a coin is much smaller, isn't it? So a coin you might estimate to be about 1/16 of an inch for 1 penny. Okay, that's 1 penny right there. That's how much you might get there. So if we had 16 pennies, here's pennies. 16 pennies is going to be equal to 1 inch, right? Because I multiply by 16, 16, and now I'm there. So that's just an idea about what that looks like. If I take out a coin, let's see in my list here, right? So take out that coin. The coin is not very thick, is it? So we might say it's about 1/16 of an inch. And it's going to take a whole lot to stack them up there. If I took 16, maybe I'd have about an inch if I had 16, just as an estimate. So now, for the 1 inch, to go to 12 inches, which is a foot, I multiply by 12, and 16 times 12 is going to be 192. All right, double check my math there real quick. Got the calculator, and we do 16 times 12. Yep, 192. So 192 pennies would be in 12 inches, which is the same as what? What do we say? Oh, I'm off the screen here. Sorry. As a foot. So then, to multiply for how many are in 5 feet, we multiply that by 5, and we end up with 960 pennies. So it's going to take 960 pennies to get there. So again, if I'm going to draw my lines here, these are going to be microscopic little marks there to show me what 960 is going to be. So every time I took that 5, here I'm taking the 5 feet and I'm dividing it by a foot. Here I'm taking 5 feet and dividing it by, in this case here, not a foot, I'm dividing it by a third of a foot, right? 2/6, right? Because it takes 2 inches there. I'm dividing it by 1/3 of a foot, something like that, or actually, yeah, that's fine. By 1/3. Over here, we're dividing it by even more. We're dividing it by like 1/20th. It's 5 divided by 1/24th. And over here, we're dividing it by even more than that, by 192. So every time we're dividing it, we're getting it small, getting a smaller and smaller and smaller number. This is 5 really divided by 192, or 1/92, like that. So crazy numbers there. So we can see we're making smaller and smaller segments each time. Now it says a stack of books is 72 inches tall. Each book is 2 inches thick. Right? Which expression tells us how many books are in the stack? So we have a stack that's 72 inches tall, right? And we're going to take that 72 inches here, and we're going to be showing how we're going to divide that into 2-inch segments, right? So the whole thing is 72, and each segment is going to be 2 inches, and we want to show how many are going to be in there. The question is, how many of these are going to show up? So which one of these expressions shows that? Okay. So as we think about it, well, we're taking a length, right? We're taking a length here, 72, like we said, and we're going to break that up into 2-inch segments. So am I increasing, decreasing? What am I doing exactly? Well, I am taking the 72 and I'm dividing that up into 2-inch segments. So that would be choice D right here. Take the 72 and we're dividing it by 2, which in this case means I would end up with something like, I can think about being 2 times how many segments are going to be equal to 72. And that's part of that process right there. Okay? All right, so number 3. 3 says another stack of books is 43 inches tall. So we have a stack of books. It's 43 inches tall. Right? The whole thing is 43 inches tall. Each book is half an inch thick. Right? So we have a book here that's a half of an inch thick, another one that's a half. Write an expression that represents the number of books in the stack. So what are we doing? We're taking that 43, the total height, and we're going to divide it by the thickness of that book, which is going to be, in this case here, a half of an inch thick. Okay? So that's our idea. We have the total amount, and then we're going to be dividing it up into smaller segments, dividing it up into chunks of a half an inch there. So that might be the expression you would use for something along those lines. Okay? All right, so as you're looking at this here, we could take a look and say, well, let's look back over here. If I have 72 divided by 2, that's going to equal 36. Let's just a quick little vocab talk here. All right, so we have a couple things here. This first number is what we call our dividend, okay? This number is what we call our divisor, and this number is what we call our quotient, okay? So those are our different numbers there. The first number is kind of the number you're starting with. That's your whole. That's your big number there. Your whole, your big piece here. Your divisor is, as a definition, it's the number we divide a number by, right? So when we have A divided by B, B is the divisor. So it's a number we divide another number by. So in this case here, we're dividing 72 by the number 2, so 2 is our divisor. The quotient, on the other hand, so the quotient is when we divide a number by another number, we get a quotient. Now the easy way of thinking about that is that's your answer you get when you divide two numbers, right? So that's our quotient. So the divisor is the number we divide one by, and a quotient becomes the answer, so to speak. It's the answer you get when you divide something by. Okay, so keep that in mind, and we'll look at that in our summary statement as well. And let's look at the next activity. That's all in order. Your teacher's going to give you your group 2 sets of division expressions. Without computing, estimate their values and arrange each set of expressions in order from largest to smallest, and be prepared to explain your reasoning. Alright, so in the first set of expressions, what we have is we have 800. We have the number 800 divided by certain values. Okay, all over the place here. 800 divided by lots and lots and lots of different things. Okay, so before you put those in order, let's think about some basics here. Okay, so let's think back to some more basic numbers. If I take 4 and I divide it by 4, I end up with 1, right? You okay with that? Now if I take 4 and divide it by a larger number, like 40, then I end up with, 1/10, something like this. I end up with something that is less than 1. You see how that works out? If I divide by a number larger than my dividend, then I end up with something less than 1. Less than 1. Now if I divide a number by a divisor that's smaller than my dividend, like 2, then I end up with a number that is greater than 1. So you need to be able to look at these two numbers and say, well, how do these two numbers relate to each other? And that'll tell you how they relate to the number 1. It doesn't tell you about their answer, it just tells you how they relate to 1. So if this number is larger than this number, so if the first one is larger than the second one, we end up with a value greater than 1. If they're about the same, it's pretty close to 1. And then if we have the first one smaller, the second one's larger, we end up being less than 1. So if I want to look for something that is going to be, put them in order from greatest to least, then I have to think about the order of these numbers and how they, just kind of how they're set up here. I look and I see I have a whole bunch of numbers that are divided by 800 divided by lots of numbers. I have 10,000. I put them just in order here. I have 10,000. Let's slide them over here real quick. So we have 10,000. We have a 1/10. That seems pretty small. 800 divided by 801. That's pretty close to the same, right? So we don't have to move those around too much. This number is smaller. So the smaller the number, then we want to think about this. The small number is going to get me, when I divide it by a small number, I get a greater answer. It's greater than 1, right? So this one here, comparatively, this will give me a number that is greater than 1. This is going to give me a number that's going to be smaller, less than. So they're going to go down here. So in terms of a scale, we have 800 divided by 250, we have 800 divided by 801, and 800 divided by 10,000. Just look real quick on a calculator and take a look. You're not supposed to use a calculator here, but since we're just doing this on the video, 800 divided by 250 is equal to 3.2. Okay, 3.2. This one, we can know it's about 1, so I'm going to leave it there. But when I do 800 divided by 10,000, I get 0.08, much smaller number. So these are right now in order from greatest to least. Let's take a look at our other numbers that we're given. I have 1250. So that's going to go somewhere between that, right? It's less than 10,000, but more than 801. 1/10 is a decimal, so that's like 0.1. That's a smaller number. So my small numbers seem to go up here. $7.99 is going to go in there, right? We're basically dividing by smaller to larger in order to put them in order from greatest to least. 2.5 is going to go right in here. And then finally this one is there. And so we end up with something like that for our solution. Okay? So we're putting in order from greatest to least, and that's what that would look like. Okay? So whenever I take a large number and divide it by a really small number, I end up with a big solution, or a big quotient, larger quotient. When I take a number and divide it by a number bigger than what if the divisor is larger than the dividend, then the quotient's going to be much smaller. Okay? Let's take a look at the other set of numbers. Let's put those aside real quick. In the other set of numbers, we see they're all being divided by 25, right? Every number is being divided by 25. So we want to go greatest to least, and again, the greatest number is going to be where the dividend is greater than the divisor. So in this case here, I can see that this dividend, 5 million, is much greater than a divisor, so that's probably going to be our largest one, because the divisors are all 25. So let's put that one up first, okay? And then from there, let's work down with our numbers. We have 1,000. We have 625. I can see a 75 over here. That would probably go next. I have a 25, 24, followed by a 6, and then followed by that one right there. Now just to take a look at this, let's see what this looks like in calculator terms. So if I did 5 million, and I divided it by 25, I end up with 200,000. 200,000. If I do 0.0625, divide that by 25, then I end up with 0.0025. So definitely that number is larger than that one, and we're on the right track. Okay? So, hope you did okay on those ones there. Let's pop back over to our worksheet. So it says on activity 3, without computing, estimate each quotient. So we're estimating the quotient and arrange them in 3 groups: close to 0, close to 1, and much larger than 1. Alright? So let's take a look here. Let's look at the ones that are close to 1 first of all. And we're going to circle all those ones here. Actually, I can get out my highlighter. I forgot about that. My highlighter's too big. So let's do close to 1 in yellow. Close to 1 means that the numbers are going to be close to each other. So 9 divided by 10 are fairly close to each other in terms of the numbers. 18 and 19 are very close together, so that should be somewhere close to 1. Right? It should be pretty close there. So those are my close to 1 values there. This one here, I also like this one that's not too far off, 15,000 and 14,500. It's definitely closer to 1 than it is to being much larger or close to 0. So I like that for those ones there. For the ones that are going to be close to 0, let's do close to 0, that's fine. So to be close to 0, when we think back, we're looking for ones where the divisor is larger than the dividend. Okay? So this is smaller than that, so that's not going to work. Smaller than that. This one definitely is much larger than 9. And 1,500,000 is larger than that one. So those two right there are definitely going to be closer to 0, which then leaves me for ones that are going to be, in this case here, greater than 1. We look for a divisor that is less than the dividend. So a half is less than 30, so that's going to be greater than 1. 0.45 is less than 30, greater than 1. And 0.18 is less than 18, so less than 1 there. Alright, so those are the 3 different ways you might group those up. And that's it. So let's take a quick look at our summary. Summary statement. Here we go. So here's a division expression. 60 divided by 4. And this division we call 60 the dividend and 4 the divisor. The result of the division is the quotient. So those are our kind of terms here. Right? So we have a dividend, which is the 60. We have a divisor, which is the 4. And the result of it all is the quotient. In this case here, it's down here at 15, your answer. We don't always have to make calculations to have a sense of what a quotient will be like. We can reason about it by looking at the size of the dividend and the divisor. So here's some examples. So when you have 100 divided by 11 and 18 divided by 2.9, the dividend is larger than a divisor, right? So you get something that's going to be a little different. In general, here's the general statements here. When a large number is divided by a smaller number, the quotient is greater than 1. So a big number divided by a little number equals something that's going to be greater than 1, right? When you take two numbers that are nearly equal, so if they're like the same size, so this number divided by this number, you end up with something that's going to be about equal to 1. And then finally, when you have a small number divided by a large number, then you end up with something that's going to be less than 1. Okay? And those are our 3 little tips for the day, our summary of today's lesson, to help get you through those things. All right, so we talked about dividend, divisor, quotient, and then how those relate to one another in terms of a solution. All right, so let's pause there. We'll take a moment to do our homework, and we'll come back and check it together. Okay, here we go. Homework for Unit 4, Lesson 1. Order from smallest to largest. All right, so the number of pennies, so we're looking at the number of pennies in a stack that is 1 foot high. Notice they're all 1 foot, 1 foot, 1 foot, 1 foot high. So which one has the most, least, whatever it might be? Okay, so we're going from smallest to largest. The smallest number of pennies, books, dollars, and slices. So think about this, think about your thickness there, right? The smaller something's going to be, the more you're going to need to get to 1 foot. Like so with the pennies, they are not very thick. So in this case here, I would say, let's look what we have. We have pennies, we have books, we have dollar bills, and we have slices of bread. The skinniest one is going to be the dollar bills, right? So the dollar bills is going to be the one that you need the most of. So that, okay, I think a little backwards here. We want to know which one, let's look, sorry, which one you need the least amount of, the smallest. The smallest is going to be your thickest, right? Your thickest material. So pennies, books, dollar bills, slices of bread, we would say books are going to be the smallest number because they're the thickest, okay? Followed by bread, slices, followed by pennies, and then followed by the bills, the dollar bills, right? Because that's going to be like a thickness like this. This will be a thickness like this. The bread's going to be a thickness like this. And the book, of course, is going to be a thickness like that, okay? So it's going to take a lot more of these to get there. So that's going to be smallest to largest. Number 2, use each of the numbers 4, 40, 4,000 once to make the statements true. All right, the value of something close to 1. If we want it close to 1, dividing by 40.01, let's pick a number that is close to that number. If I want to get much less than 1, if I take a little number and divide it by a big number, then I get less than 1. And then here, if I want to get greater, I need to take a large number and divide it by a smaller number to get something greater than 1. Number 3, without computing, decide whether the value of each expression is much smaller than 1, close to 1, or much greater than 1. Again, we talked about before is if I have a number, we use our example. If I have 4 divided by 4, I end up with something that's like 1, right? If I have 4 divided by a larger number, 40, then I end up with something that is going to be less than 1. If I have 4 divided by a number smaller than the dividend, then I end up with something that is going to be greater than 1, along those lines. So here's 100 divided by a smaller number. So it's a number divided by a small number, then I should end up with something that's going to be greater than 1. Okay? Here I have a number that are pretty close to one another. 50 1/3, 50 1/4. We'd say it's about equal to or close to. Right? So probably don't say equal to, probably say close to. Those are my options. 4.7, 5.2, those are pretty close to each other, so be close to 1. I have a number, a little number, divided by a big number. So little divided by big gives me something that is going to be less than 1. Big divided by little gives me greater than 1. And little divided by big gives me something that is less than 1. Alright, moving on, number 4. A rocking horse has a weight limit of 60 pounds. What percentage of the weight limit is 33 pounds? Okay, so this is a review problem from last unit. So we know that 33 divided by 60 is how much of the weight we're talking about. So 33 of the 60 pounds. Okay, that'll give me a decimal answer. Make it into a percentage number and multiply that by 100. So 33 divided by 60 times 100 is actually equal to 55. In our case here, 55%. What percentage of the weight limit is 114 pounds? So that's going to be a lot more weight, right? It's 114 out of the allowed 60. I'll multiply it by 100 to turn it back into a percentage. And 114 divided by 60 times 100 is 190%. It's a lot more of the weight. And you can say that's almost 200%. Well, yeah, it makes sense because 60 times 2 is 120, and so that would be 200%. You can see it's getting really close to being a 200% problem. There's one more like this, part C. What weight is 95% of the limit? Okay, so now we're talking about 95% of the limit. So 95% of the limit is 95 out of 100. That's what 95% is. Okay, so we want to find 95% of the limit. The limit is what? 60. So 95% of the limit, which is 60. So 95 divided by 100 times 60 is equal to 57. So 57 pounds. Number 5, compare using greater than, equal, or less than. Okay, so we have 0.7 and 0.7. The 0 means nothing. I could put a million zeros. It doesn't say anything different. So this is going to be equal. So here we have 0.03 and 0.3 plus 6 over 10 plus 6 over 100. So 6/10 is going to be, as a decimal, that's 0.6. So I end up here with 0.63 is what that looks like. This is 600, so it's 0.06, so that becomes 0.36. So this is going to be greater. And then over here we have 0.9 and 0.1. That's going to be a larger one there, so we're going to go that's bigger. Alright, and in this one, if you weren't sure, if you wanted to put a 0 there to make them hundreds, you could, and now you can see if 90 is bigger than 12, right? Okay. Diego has 90 songs on his playlist. How many songs are there for each genre? So he has 90 total. We want to find out 40% are rock. So that's 40 out of 100. Alright, and we have 90 in our playlist. So it's basically 0.4 times 90, which is going to be 36. Here we have 10% out of the 90, which equals, in this case here, 9. 30%, 30 out of 100, times the 90 that we have, ends up being 27. And the rest is electronica. What's the rest? We have 40 plus 10 plus 30, so that's going to be 50, 80%. So we're talking about 20%. So 20% out of 90 is going to be 18. All right, and that's it for number 6. Number 7, a garden hose emits 9 quarts of water in 6 seconds. So 9 quarts of water, so we have quarts, we have seconds, 9 quarts in 6 seconds. How long will it take the hose to emit 12 quarts? Alright, so to find 12 quarts, we could do it a couple different ways. We can turn this into a 1 by multiplying by 1/9, which means we multiply this by 1/9, so we have 6/9. And then to go to 12, that's times 12 times 12, and so 6/9 times 12. Well, 6/9 can also be reduced into what? 2/3. It's a little nicer, right? So 2/3 times 12 is going to be 24 divided by 3, which is going to be 8. So we'd say 8. How much water does a hose emit in 10 seconds? Okay, so let's flip this around here. So we're going to say if this is 10 seconds, how much of this goes over there? Well, our constant proportionality was 2/3, so we flip that around and multiply it by 3/2 by the reciprocal. And that's going to give me 30/2, which is going to tell me it's 15, right? So over here we multiply by 2/3, and over here we go by 3/2, so we end up with 15 quarts. Works there. Alrighty, and that's all there is to it. Okay, that's it for today. We will see you next time.